share my screen as well. Okay. So yeah, just before we get into the details, yeah, maybe for better clarity, storage is where we store the data, right? Either for the business application or the log or whatever we accumulate for security analysis. So we need a storage either for the business data or for the personal information, storing personal information. We use different type of storage. So primarily, predominantly on the business side, we use the block storage for your application root volume or the boot volume. We use the block storage where we have the applications, the OS apps, the data will get mostly stored on the block storage, including the database and so on. And we have another category called file storage, where we generally store the file shares for your departmental shared data or um, the home folders for each and every users and so on. We use file shares where the file system has to be accessed from multiple end users or multiple servers. If we need to access a kind of file system, then we go for the file storage. And we also have a category called object storage. This is an internet based storage, or this is more of a WAN accessible storage, where you have the likes of Google Drive, you have OneDrive and other things, right? So here AWS also provides you Amazon S3, which is one of the very popular service that is being used by customers for various use cases and scenarios. So object storage is something which we will discuss later. And along with this object storage, we also have the archiving solution, which is pretty much integrated to S3 called S3 Glacier. And we also have a solution natively from AWS on how to take backup of the block storage, file storage, and the object storage. So they also give you a native solution to take care of the data protection part. So today we are going to discuss the block storage and the file storage, which are closely integrated with your EC2 instances. So when you have a EC2 instance and you need to have if you want to have some storage attached to it, if you want to store the data, then you go and create a EBS volume, or you go and create a EFS file system to store the data. So these are the two commonly used category. So earlier, EBS volume cannot be multi-attached, right? So it is more or less one-to-one mapping. Even now, most of the volume types are one-to-one mapping. If you create a EBS volume, it's like a drive that you create on your SAN storage, or when I say SAN storage, storage area network or network attached storage. So you actually provision the volume, and then you provide it on the network, either to the fiber channel cabling or the network cabling, and you access it as a network attached storage, or a storage attached network. And the file system, generally we access it through a network protocol, like your NFS, network file system, or Microsoft SMB file system. There is another equivalent solution from Amazon for SMB. SMB is server message block, right, which is native file system from Microsoft. And for accessing that, Microsoft has got this native server message block protocol, and for accessing through that, Amazon has provided a solution called Amazon FSX. So Amazon FSX has got multiple variant, even for high performance clustering, or there is for Linux clustering, there is something called Lustre, and for Windows, they have got Amazon FSX for Windows. And even for other categories, if you want to migrate some data from on-premises to the cloud, maybe if you are using NetApp storage on the premises, and if you want to migrate that to the cloud and you want to use the same functionalities, features, and stuff, you can use Amazon FSX for NetApp and so on. So that those object storage or Amazon FSX related topic is something which we will discuss next week. So today we will try and cover as much as possible around the block storage, which is kind of presentable to the EC2 instance, the compute topic that we have been discussing since last couple of days. Right. So EBS stands for Elastic Block Store. Maybe let me just create a separate file here. So if you have a EC2 instance, there are two type of volume that you can attach, okay, at a high level. One is the EBS volume and the other one is the instance store volume. So the EBS volume is nothing but elastic block store, that is the abbreviation. And the instant store is a kind of local storage. As I explained, EBS volume comes from the storage area network or network attached storage, either through SAN cabling or your direct I2C cabling, or even sometimes through the network cabling. We present this data, and there are multiple volume types that are available. We will discuss the volume types, and then when to use each of those use cases we will discuss. But then instant store is local storage. So every server in the data center will have its own local capacity. There might be a 8 drive or 16 slot that is available directly on the physical server. So those slots will be filled with some kind of SSDs and hard disk drives. So those local storage on the same physical server, so those are all provisioned and made available for the EC2 instances as a instance store. So that is local storage on the physical server itself. So there are some pros and cons of both the types, and I will help you on when to use each of these options, right? So this instance store is primarily a local storage, and it comes free of cost. We don't have to really pay anything extra, but you cannot have the production data there. You can just have use it as a temporary store, or people call it as ephemeral storage. And you can store data, and then primarily you can use it for caching purpose, or you can use it for swap file paging, and so on. So that is the primary use case for this instance store, and that is how you use it, right? So let me Okay, let me come here and then try to see. So yeah, EBS volumes are network file systems. It is pretty much similar to EFS, but the way that you access it through is different, right? So EFS is accessible through the network file system protocol, or the server message protocol. We are accessing it through some specific protocol. We are creating a file share, and we are mounting the file share on the server. Okay, either we call it as mounting the file system on Linux system, or we call it as mapping the network drive on Windows servers, right? So mapping, mounting. So we kind of utilize the file systems to do that. But then in block storage, it is accessible directly through the OS itself. And again, we use the OS level block file systems for partitioning it, and then creating chunks of the physical storage, and we create a block storage using the native file system from the operating system. Either it can be the ext3, or the Windows native file systems like NTFS or REFS, resilient file system. So there are many different file systems native to operating systems, Windows, Linux. So we predominantly utilize those, leverage those file systems to create equal chunks of, that's why we call it as block, right? Equal chunks is what we call it as blocks. And then we utilize it for our operating system, boot files, and so on. So this instance store, you can use it only for certain caching purposes. For example, if you are creating a memory analytics server, or maybe you're creating some database server. So generally those systems need a kind of catching, or in order to improve the performance efficiency, we have something like the temp database that gets created, right? In addition to database logs and the transaction logs, we also have the temp database. So if you want to quickly store and access the temporary database related content, or if you want to utilize some caching, or if you want to do some swap file configuration for your operating system to enhance the performance if the physical memory is not fully available, what you can do is you can leverage the virtual memory, right? So the virtual memory is called as swap file. So you can use those page file or swap file or caching or temp db. So these are the ones which you can leverage for instance store. So this instance store does not store the data. For example, I have a EC2 instance, right? So this EC2 instance is currently running on a physical server one in AWS data center. right? So what will happen is this EC2 instance is getting this instance store directly from the physical server through the internal physical server communication channels, like through the motherboard and all those things. So if this EC2 instance, for some reason, if it gets migrated to another physical server, right? Server 2, if in case of any issues on server 1, or the performance or the expected resources are not available on server 1, this EC2 instance get migrated to another server, physical server in AWS data center, the connectivity of the instance store get lost here. So when the EC2 instance get migrated to a different physical server or different location, the instance store will get cleaned up. So instance store is meant for improving the performance of your application or database or whatever purpose, like for your operating system. If you want to utilize the virtual memory or caching or temporary database for your database relational database systems, so you can use this instance store, but the instance store will be intact. It is not permanent. It is a temporary in nature. So if your EC2 instance get migrated, see, it is not going to happen regularly, right? Once in 6 months or once in few months, maybe your EC2 instance will get migrated to a different server or a different location, and that is the only time you will get impact on your data. So otherwise, you will have continuity on accessing the data. If the EC2 instance continue to run on the same physical server for 1 year, 2 years, or more than that, there won't be any impact on your instance store. But as a solutions architect, we have to be very careful. Whatever the data that the customer stores on the instance store should not be a critical data. It is not a permanent storage. It is a temporary ephemeral storage. Whatever the data that the customer, for example, you are downloading some ISO files or some large files for some installation or some interim measure or for some temporary requirement, you can utilize those instance store. But then you should not use that instance store for any mission critical data, or you should not configure any application or database related content on the instance store. But the temporary database, the virtual memory, caching, those can be configured, because you will get better performance on the local storage, right? So because this EC2 instance is running on the same physical server, and the same physical server provides you that local storage disks, so it will be definitely good for any caching or in-memory analytics or similar use cases. But majority
Can.
people will, yeah, go ahead. Yeah.
Okay, sorry to stop you.
Yes, yes,
Stan,
yes.
see, you are talking about a Linux server.
Mm-hmm,
Say, for example, I am running a Windows machine,
mm-hmm,
okay, on a on a on a on a physical server with I have an internal storage, as
mm-hmm,
you said, instant store or
mm-hmm,
whatever it is. Okay,
mm-hmm.
um,
Go
we
ahead, go ahead.
generally have on a
Mm-hmm,
we generally have a on a local machine. We used to have local profiles created on a Windows server. See, say for example, I'm logging in, then I will have my local profile created. Uh, when I when this Windows machine migrated to a different machine, so still that local profile also will get migrated, right? I mean, in that case, it will not be a problem, is it
okay.
correct?
Yeah,
Eh,
you are
eh,
right. It
uh,
won't be a problem. So, see, when you are launching an
okay.
instance, so you have to
Uh,
be, let me show you this. Operating system, free trial, pricing model, infrastructure support.
I'm keeping myself mute. Okay.
No, no worries, no worries. Yeah, yeah, I got it. Okay. So, see, there are two type of physical, I mean, the device types that are available for your for your EC2 instances. And the EC2
Hmm.
instance will generally, let's say I have a EC2 instance, and generally I will have a root volume or a boot volume, or you can call it as a OS volume, right? In addition to that, you will have some secondary storage for maybe paging or caching or swapping purpose for some temporary requirement, and then you will have the data or database related content stored, and you might also have something like applications or apps volume, and then you will have data volume, and then sometimes people will have a separate volume for logs and so on. And there might be some cases where they might also have a temp database for your relational databases. Now the root volume, the OS volume, this will have all the installed apps if you are installing it on the default drive, or it will be on the apps volume. So it depends on case to case, and whatever the OS user related profile, if you are configuring it on the root volume, it will be there on the root volume, and the data it will be on the data volume if you have configured it on a separate partition. And sometimes you might also have a EFS share or a file share which is mounted from a external storage, that is the EFS file storage. Some home folders or some department shared data will be here in the EFS share. So now the instance store is applicable only for the secondary volume where you configure the virtual memory or caching or paging or temporary database and so on. So whatever you talked about, the user profile, either it will be on the root OS volume if you're talking about the local users which gets created in the OS. But if it is
Mm.
user profiles, home folders, most of the cases, it might be on a network file share, which is like in AWS, we call it
Okay.
as EFS file share and so on. So this data is mainly
Mm.
for enhancing the performance of your database or application or your operating system by giving you additional memory space from the local physical server. But then the
Okay.
EC2 instance will get the root volume from the EBS volume, right? So this will be
EBS
EBS
volume.
volume 1 and then EBS volume 2, and then wait, when it will be like that.
3.
Yeah, something like this. So you'll get multiple EBS volumes created for your OS data, database apps, and logs. So this will be persistent. So EBS volume is persistent in nature. It is permanent. So it will not get impacted irrespective of any movement or whatever. See, the EBS
Okay.
volume is a shared volume from a SAN storage or from a network attached storage. So the EC2 instance, either
Even
it,
when the server
yeah,
getting migrated,
correct.
it'll automatically move
Correct.
with that.
Yeah,
Okay.
it
Got
it
it.
will
Got it.
continue to
Got it.
have
Yeah.
network access. So the EC2 instance will have continued access to the EBS volume irrespective of the server it runs, because all these physical servers will get connected to the SAN storage either through the fiber cabling or through the network I mean the regular LAN cabling. It will be connected. It will stay connected. So irrespective of the EC2 instance running on any server or any availability zone on the same on the data center level, it will still have the connectivity intact, and there won't be any loss to the data, or the connectivity will be the data will be accessible if it is EBS volume. Okay, so instance volume is an exception which is given as a free of cost by AWS to enhance the performance or user experience for certain use cases. You got it right. So the home folder
Yeah.
or the user profile, it gets stored in the network file share or in your root volume or whatever. So now let's go and have some systems created. See, when I go and create a new system, it gets launched with the default OS volume. So if you look at the options here, so you'll get a default 8 GB if it is a Windows, and if it is a Linux, sorry, if it is a Linux, it will be 8 GB. If I choose Microsoft Windows, there are a lot of programs and apps that gets uh, automatically pre-installed in Microsoft Windows operating system. They give you 30 GB. So when you talk about free tier eligibility, so 30 GB is free of cost for either a general purpose EBS or magnetic storage, which is a legacy traditional storage from the what do you call? There are two categories, right? In general, we have this SSD drive, which is the latest flash drive kind of technology, where the performance and efficiency will be more. We used to have this hard disk drives, which is nothing but your um, you might have seen the picture of hard disk drives, right? So it used to have this I mean, what do you call the plater So it will have it is the older technology, right? It will be like this. So it uses a different like a CD drive or something similar to that. It uses the spindle plater and reads and writes. The performance will be comparatively slow, but SSD is a flash drive. It is all made up of NAND flash memories, so it will have better options for catching. Controller will be there. So SSD by itself will have its own catching, and the performance will be much better. So these are the two technologies that are predominantly used. HDD is the traditional old one where we call it as magnetic drive, and this is the flash drive current technology where it has got inbuilt catching, and it's all chip based, and it is very highly performant. So solid state drives are mostly used for majority of the use cases, except for some basic use cases like backup, or if you want to store some logs, or if you want to collect some events, or if you want to store some infrequently accessed data or archive data, you can go for hard disk drive when it comes to saving the cost and so on. See, as a solutions architect, always keep few things in mind. Okay, so when you are learning some topic or product or service, as I said on the very first day, a couple of you missed the first day session, right? So understand the features and functionalities of that particular product first, right? And then you need to understand how secure it is, the security aspects, and then the security compliance, whether it meets the compliance requirement of that particular industry vertical or particular region you are working with the customer, right? And then you will need to look at the performance of the service, whether it has got the adequate performance, and then you have the cost which has to be thought upon. So you always have to think from all these dimensions when you're providing a solution, or when you want to have when I say cost includes the billing and those aspects, right? So understand the topic from all these dimensions. So generally, like, you need to understand what exactly is the service, and then what kind of security aspects it brings to the table: performance, cost, security, and features and functionalities. So if you understand all these areas, so you will be able to confidently communicate with the customer, as well as you can provide the solution holistically by thinking all the aspects. So one more thing I always tell the architects, that they also have to think about operations efficiency, whether the solution that you are implementing is supportable by the run team, the regular routine operations team. The operations efficiency has to be measured when you are solutioning something. If your team is not equipped with those skills, or they are not having the right level of experience and exposure with those technologies, you have to inform the lead to get them the training that they need, and then make them equipped with all the necessary inputs and stuff that they need to support that particular environment. So from a solutions architect point, so you need to check whether your organization has that capability to support that environment which you are solutioning, which you are designing, right? So if they are not, then you have to give a heads up and then call it as a risk to the support team lead, and then they will arrange the training and quickly bring all that efficiency in place. So otherwise, like, you need to think from performance, cost, security, and features and functionality aspect. So that way, any solution that you give, if you are understanding the product from these five dimensions, you will be very much confident in anything that you talk about, or anything that you provide as a solution, right? So coming back to the EBS volume. So as I said, EBS volume is the block storage, where predominantly it is used as a storage volume to store your data for your Amazon EC2 instances. So you actually attach it to the EC2 instance when you create it. So for Windows, you get 30 GB, and for Linux, you get 8 GB of volume. So maybe let's say, let me quickly give it some name. I think we have been creating a lot of Linux. We'll create some Windows VM quickly. But then the capacity is very less for Windows. You will get only, 30 GB to play around. So I think this is what we created yesterday. Let me create one more PIM file. Stan win key 01. I will just name it as 10th of October. Okay, so RDP is allowed, 30 GB is fine. And if you want to add any new volume, you can add it here at the time of creation, or if you want to add later also, it's fine. See, if you look at here, so it gives you options to create in an 8 GB increment. Okay, so I will just give some 4 GB for now. See, in cloud, in public cloud, you will see instead of KB, MB, GB, you will see KIB, GIB, MIB kind of thing. So it is little different, slightly different from how we used to deal with on premises, right? In on the premises, we used to have kilobyte, megabyte, gigabyte, and so on, right? Terabyte, and it keeps going. Exabytes, petabytes, exabytes, and so on. So these are all decimal way of calculating stuff, right? Thousand square, thousand cube, and so on. But in the cloud, the machine is provisioning the storage. So there is no human intervention, or at least there is less human intervention in the public cloud. So where they provision it through in binaries, so kilobyte, megabyte, giga, tera, peta, and so on, right? Here, what we call it is, instead of kilobyte, we call it as kibibyte. Instead of megabyte, we call it as maybe byte. Instead of this thing, we call it as GB. So this BI stands for the binary, right? Instead of decimal way of provisioning, we are provisioning it through binary numbers, so which is like 1024 square, and 1024 cube, and so on. So there is a slight difference at the beginning, but when the
It
data
it
grows,
still it
no,
still
no,
remains the same, right?
no, no, it's
Okay,
1000 square, 1000 cube. Here it is 1024,
okay,
1024 square. Like where there is a very
okay.
minimal byte difference
Ah,
at the beginning, but when the quantity grows,
got it.
it's evidently visible.
It'll be, yeah,
Uh,
it'll
uh,
correct. Got it. Okay.
yeah. So here it is GB byte. You have to read it as GB byte, not gigabyte, right? It's binary. So that's why they have
Understand this
differentiated.
additional storage is instant store or EBS? This additional
No, this
storage,
is EBS only.
EBS. Okay.
Yeah. So instant store, you have to provision it separately. So this is EBS only. And then, so let me also have, maybe let's only have one for now, and I will give you some more examples on how to play around with that later. See, as a solutions architect, obviously you don't have to really get into the a lot of hands-on things, but if you get time to do that, then you can do it. Let me launch it, and then I will show you some useful tips here. Okay, I mean, as a solutions architect, you might get into a scenario where you have to provide a solution for different use cases. There are various types of options that are available from Amazon when it comes to EBS. It is not just one type. So EBS has got at least 7 different types to choose from. Okay, so let me just give you the list of options. So similar to the EC2 instance type that we discussed, everything, any option in cloud starts with a general purpose option. So general purpose, as the name indicates, you can use it for a workload if you don't know what kind of expectation that the workload is expecting from us. So general purpose is general purpose, right? You can use it for any application workload or database or any kind of web servers or whatever, right? But then there are other specialized categories like, for example, provisioned or different volume type that you can use for your in case studies. So volume type, we have general purpose GP2, and then we have GP3. So when you have two different options to choose from the same category, always go for the latest generation. So either if it is general purpose 2 or 3, or IO version 1 or IO version 2, always go for the latest generation. The reason is it will be having a lot of performance. The technology will be latest, and the sizing, the capacity option you get for scalability will also be high, and you will also get a good amount of cost benefit as well when it comes to the latest generation of the option. So general purpose version 3 is the latest one, and IO version 2 is the latest one. And within IO version 2, I think there is one more option called Block Express that is having even much more additional support. See, when it comes to the SLA expectation of your application, right? There are the availability aspect, and then people call it as durable. So you might have heard this in some products, right? Durable, how durable is your product? So durability means like how long your the lifetime of that particular product that you purchased, or here the failure rate of the storage or the system, right? So you will get a very high availability for both general purpose version 2 and version 1. So which means like 99.9, 99.8 to 99.9 is what they are guaranteeing. So which means the remaining is the failure rate, the chance of failure, right? So the annual failure rate is point, point 1 to point 2. So I'm just subtracting 100 from here, right? So 0.10 to 0.20 is the annual failure rate. This is the percentage of failure possibility for your general purpose. Whereas here, for your provisioned IOPS, it is much better. For your IO version 2, IO version Block Express, they provide you 99.99 999% of the, I mean, let me just, so they, okay. Just give a second. Okay, so 99.999. So where the annual failure rate, the AFR annual failure rate, right? AFR stands for annual failure rate. So AFR is the remaining out of the 100 there, right? So 0.001. So they, you get a very good availability for your IO version 2 Block Express. Pretty much this is the same for IO version 1. So you get 99.8 to 99.9, and the annual failure rate is pretty much similar for IO version 1. So the provisioned IOPS workload. See, I think a couple of you were asking about virtual desktops and all those things, right? So the general purpose is good fit for VDI solutions, virtual desktops, and then for any transactional workloads, you can go for this. If your workload is very medium sized, or medium sized web server or app server, then general purpose should be a good enough option. And for most of the boot OS volume, right, we will be using this general purpose. Okay, comparatively cost is cheap. So if you have some interactive application which needs low latency, or if you are going for dev environment or test environment or pre-prod, then go for general purpose. Provisioned is for production category workload. So where if you have a need for sub millisecond, see most of the GP general purpose 3 or the IO version 1, it is millisecond latency is what you get. Okay, it is much faster. So it is in AMS only, millisecond only. But then if you want sub millisecond, which is much faster latency, if you want to have low latency and access the resources very quickly, then you can go for IO version 2, which gives you sub millisecond latency, and also the performance that you get is very sustained actually. So you'll get a continuous same input output per second continuously. The performance will never degrade. It will be the same level of performance you will be getting from the IO technology. So they call it as IO Block Express, IO2 or IO2 Block Express. So both are same. Okay, so there is a kind of chip, or a latest technology Block Express chip, that provides you this kind of benefit. So if you want to get more than 64,000 IOPS for your application, then you generally go for the IO Block Express. Whereas in IO version 1, you get close to 64,000 IOPS, or I would say 1,000. Let me just 64,000, and more than 64,000 if a customer is expecting for their application, then you can go for IO Express, which gives you that level of speed and throughput. So which is nothing but somewhere around 16 kibibyte IO is what you get. So I think you can go up to, if I'm not, 2 lakh 50,000, 56,000 IOPS is what you will get in IO Block Express. So you get so much, but then there might be a little costlier stuffs that are associated. And also, if you want to attach this Block Express technology to multiple EC2 instances, the multi-attach feature is available only in this IO Express, which is provisioned IOPS category. Okay, so general purpose is one-to-one mapping. If you create one EBS volume, you cannot attach it to another EC2 instance unless you detach it from that existing EC2 instance. You cannot attach it to a different EC2 instance. It is one-to-one mapping. Whereas the provisioned IOPS IO version 2, it supports, even IO version 1 supports multi-attachment. So they call it as EBS multi-attach concept. So if you, for example, if you have some clustering and if you want to have the same volume accessed by multiple servers as a clustered node, you can use this provisioned IOPS for multi-attach. And again, there is a technology that they uses on the IO Block Express called NVMe technology, non-volatile memory express technology. So that is the kind of chip or the reservation technology that they use for getting that level of performance from the system. See, when we say IOPS, it is like input output per second, but some customers will give you an expectation using throughput. Okay, so they will say I'm expecting maximum of 250 MBS, which is like again maybe bytes per second. And if you are if you want more than 250, then this GP3 provides you 1000 Mbps speed, and then this one provides you up to I think again 1000 only, not beyond that. And this provides you up to 4000 because of the non-volatile memory technology that you get from IO to Block Express. So there is a lot of enhancement in IO Block Express. So if your workload is very sensitive, very mission critical, and it needs a lot of throughput, latency, and capacity, you can go for IO version 2 Express. But if you want to have a cost optimized workload, or if you want to have save some cost, you can go for GP3 or IO version 1, which is comparatively very cheaper. But the size also, it is important, right? So when you talk about the capacity that you provide, the size that you get, so you get up to 16 terabyte size you can provision on all these three, right? 16 terabyte, but you can have it in 1 GB increment. Okay, 1 GB increment is supported, whereas here in IO version 1, you have to provision it in 4 GB increment, and then you can provision it up to 16 TB byte. Sorry, TB byte, and then I think it will be okay. Fine. So here it will be 64 TB byte is what you will get in. You get up to 64. That is very huge, right? So if you want to have storage capacity of more than 16 TB, IO Block Express is the only option that provides you that. See, besides these four categories, if you want to go for traditional options like the throughput optimized, so if you want to store some log files, or if you want to have some big data concept or data warehousing and those use cases where you are talking about too much of storage and cost effectiveness, then you can go for another option called throughput optimize. This is mainly for your workloads. Name itself, it is throughput optimized. Okay, I'll show you where exactly you can find it, but these are all HDD category, throughput optimized, magnetic. These are all very legacy ones. Okay, HDD, the magnetic option. Magnetic is very old one. Okay, so and then you have this cold volume also. Cold is mainly for archiving. From the name itself, you can see it is the lowest cost storage. It is very cheap. And if you want to do some archiving or some backup, or if you want to store some infrequently accessed content, then you can use this. But throughput optimize is mainly for the big data related storage, or if you want to store some log volumes or a data warehousing. So mainly where only storage is the point, you can just utilize this throughput optimized. It gives you the same amount of capacity, around 16 terabytes, and the maximum IOPS you get is around 500 IOPS is only what you get in throughput optimized. And cold is pretty much very slow, but then you can access it. Okay, when you need it, you will be able to access it. And then the throughput is also like kind of 500 mbps and 250 mbps to these things. So now I should have the instance available to launch or access. Okay, let me show you the step on how to access the Windows instance. Yesterday we thought of trying it, but we could not complete that. So if you click on connect, so it will ask for the specific PIM file to get the password. Okay, so click on this and then it will ask for the relevant key. You have to select the private key from your local machine. And then once you provide it, you will be able to decrypt and retrieve it. So this is the password that it generates. You can also get that changed whenever you want it. But for now, this is the default credential for your Windows instance. Administrator is the username, and the password is what you have to generate using that PIM key, the private key file. So I'll show you how to connect from our local machine from the internet. You need to have the public IP address in order to access it. Okay, so it is able to log in to the EC2 instance. Once after I log in, now predominantly we are discussing about the EBS volumes and the storage. Right, let's go and see what kind of disk options we have got. And if you want to have more volumes created and assigned, you can go to this volume section here under the Elastic Block Store. And you have two volumes created. One is for the root volume, and I've also added a 4 GB volume to that same system. So this 4 GB volume which I've created, it has got this particular IOPS and speed and capacity. So one important thing that as a solution architect we need to be aware of is, like, when you have more capacity, the content can be typed across multiple volumes, multiple disk in the physical storage or in the SAN storage. So when you type the volume, when you type the data into multiple disk, you get more throughput, more bandwidth for your applications or for your operating system. So when you have very less size of capacity, the IOPS, the throughput that you get will be less. So there is a ratio for it. For example, if you're talking about 100 GB, you can get up to three times, right? 3000 IOPS. If I'm just going for 300, then you can go and increase the IOPS up to 16,000. So there is a way to go and change it and utilize the maximum possible. So these are the types that are available. Okay, so general purpose version 2, version 3, IO1, IO2, and then the cold disk, throughput, and magnetic. So these are the 7 types that I was listing it there. So if by default, the default option is GP3, that is the recommended option for most of your workload. But if you want IO version 2 and if you want 256,000 IOPS and 64 TB capacity, then you have to go to provision IOPS version 2. And if you want to go and provision it for some infrequently accessed data or some archiving content, you can go for cold disk. So there is a kind of important thing. The minimum storage that you can provision from cold hard disk is 125 GB, and maximum you can go up to 16. Whereas if you go to general purpose version 3, even you can start as minimum as 1 GB, and then you can go up to 16 GB, terabyte. But if you're talking about provisioned IOPS, it is in 4 GB increment. So you will have to provision minimum 4 GB, and you can have 4 GB increments up to 64 terabyte. So the provisioning minimum maximum differs, and then the increments also differs. For general purpose, it is 1 GB increment. For provision IOPS, it is 4 GB increment. And for cold disk, you start with a minimum of 125 GB. That is where you can either you use it or not use it. When you want to when you provision cold disk, it is very, very cheaper. It is dead cheap. So that's the reason they want to give some amount of option or some capacity so that you utilize it. And then the magnetic or very old option, you get only less hard disk drive, right? So hard disk technology are getting deprecated, so it gives you only 1 terabyte of space, and hard disks we don't get a lot of space. But nowadays in SSD disk you get a lot of capacity, and when you type the data across multiple SSD drive, you get flash kind of performance, you get a lot of IOPS and throughput. See, for magnetic they are not guaranteeing any kind of IOPS or performance, but then if you go for provisioned IOPS, they are giving you option to go and provision the IOPS that you need. For example, I can say I need only 1000 GB, but then I need up to let's say 6000 IOPS. You can provision it. Okay, that's the reason it is called provisioned IOPS. You can provision the capacity as well as you can provision the IOPS that you need for your sizing. So there is a ratio that you have to follow. So up to 1000 IOPS per GB. 1 GB you can get up to 1000 IOPS. That is a very good amount of input output per second per GB, right? So if you go to IO1, you will get only 50 IOPS per GB. So this is where the performance characteristics heavily differs. If you are solutioning something, keep this in mind. So if you are changing from IO1 to IO2, you will see a drastically complete different performance, because per GB you get up to 1000 IOPS in provision IO version 2. And see, if you're going for general purpose, you will get very less. So you get only 1:3 ratio. So 3 IOPS per GB. It is very, very less. Okay. So understand all these things, and then when you solution it, understand the cost impact as well as the benefits that the customer is looking for. If the workload is very critical, where you need a lot of performance, throughput, latency is very, very important, you go for IO version 2. And if the capacity is very huge, you can also utilize the IO version 2 block express option. So now coming to the storage that we have provisioned, you can go to the disk management from the start menu. So currently I could see that the 30 GB volume is already partitioned, and you can see that it has got a C drive assigned to it. And you can also see that there is a 4 GB volume which is already accessible, but it's not initialized. So I have to bring it online, initialize it, and then I can create it based on the size of the disk that we have provisioned. If it is more than 2 terabyte, you can go for the GUID partition table. That is the one it supports more than 2 terabyte. If it is less than 2 terabyte, you can either go between master boot record partitioning layout or the GPT partitioning layout. So I can choose anything, and then I need not create the complete size. I can also use 2 GB for now, and then later I can use the remaining. But ideally, whatever you have provisioned at the AWS platform level, you have to pay for the entire 4 GB, whether you use it or not use it within your operating system. You have already reserved 4 GB at the AWS platform level. You have obtained it from AWS already, so you have to pay for it. So always go for the full capacity. But if in case you want to expand in the future, you have the option to go and change it. So for example, if I want to change that volume, so I can just go and say I want more space. I can just say modify volume, and I can just say I need additional capacity, and I can modify it. So that way you will get option to increase it. But decreasing it's not possible. You have to take a snapshot, and then you have to create a new volume with a lesser size. That is a main option. So now you can go to actions and then rescan it. So you will see additional 4 GB free space after the rescan is complete. So that way you can directly add more capacity. See, I could see 4 GB unallocated plus 2 GB is already there. So it's total of 6 GB. So if I want to add more volume, I can also do that. So I can just go to volumes here, create a new volume. So whatever type you want, you can create it. I'll just create 2 GB for one more drive. And then see, this is very, very important. If my system is in data center 1A, so the volume also has to be created in 1A. See, if I'm creating it in a different data center, then you won't be able to provision it. See, currently the server is in 1B. See, purposefully I'm creating it in 1A. Okay, so just for better understanding. Okay, so I have created it in 1A data center. See, and then I'm trying to go and select that 2 GB volume. From the actions menu, if I want to attach this volume, so I don't see the option yet. The reason is it is still getting created. Okay, don't worry about the options for now. So it is getting created. Always look at the state here. Even if you move on to the right, you can see that the status is here, right? And also, when you are trying to make some changes, wait for the optimization to complete. This optimization is because of the increase in size that we did. We increased the size from 4 GB to 6 GB. If you are making another change while the optimization is happening, there are chances of data getting corrupted. Okay, so don't always look at the volume state as an operations engineer before you make any kind of additional changes to the volume. Okay, if the volume is in use and ready for changes, it will say in use and green. If it is in use and optimizing state, don't make the additional changes until the optimization is complete. So that will have a performance impact, plus it might end up corrupting your data also. So wait for some time. So this is available now, right? Even if it is available, if I go to the attach option, I will only see the instances from the same data center. See, it is clearly saying there is no matching running instances in AP South 1A. So these volumes that you are creating is bound to a data center, bound to a availability zone. So these are all tied to a data center. So if your server is on availability zone 1B, then you have to create the volume in the same data center. So if I want to just attach a new volume, then I have to create it in 1A only. See, the other two volumes are already in, other two volumes are already in 1B. So I have to create the volume in 1B. So that is where you have to be very, very careful. So as an operations engineer, as a project engineer, when you want to create a provision of a new volume, you have to create it in the correct data center. And I can also create a new volume from the existing snapshot. So for example, if I have, if I've taken a snapshot yesterday, right? So if I want to have those content into this volume, I can also create a new volume from a snapshot reference. So that way, whatever the data that is there inside that the snapshot will also be made available in the volume. Okay, so let this get created. It's getting created. So this volume, I cannot use it unless I have a new VM created in Asia Pacific South 1A. If I have one server created on 1A data center, then I can attach it, or else go and remove that, delete the volume. So when you are deleting it, just ensure that it is detached before you delete it. So that way there is no impact. Okay. So first detach it and then wait for some time, so that if there are any complaints or any data loss, you can try to reattach it again. So detach and then delete it. Now we have successfully deleted that, and even this volume is now available. If I go to attach the volume, now I will see the instance which is running on that particular same data center, stan Windows VM1, and then I can give it a label. So this is based on the partitioning, right? So if you have multiple volumes, you can select C, D, E, F, and so on. So for Windows, this is how it gets assigned. Okay, so /dev /xvd cdada and so on. So and for the root volume, you get SDA1, SDA2, and so on. For the data volume, you get XVD followed by CDEF and whatever the number of partitions we create. If you want to have your own fancy thing, you can also select XVDS, and then I can attach it. Okay, so generally you can relate it.
These stand,
Mhm. Yeah.
so stand like these standardization are for standalone servers, right? In case of cluster,
Hmm.
for high availability, we will have different region, different
Hmm.
availability zones just
Hmm.
for the you know if one in the disaster recovery, like we can switch to the other.
Hmm. So see, I'll come to the clustering shortly. Okay, so here in this case, so I've now attached the volume. See, generally these attachment label or whatever, right? Just a second. So the labeling that you have, it has got some meaning, right? What you can do is like you can also use the same labeling inside the operating system to relate it. For example, I have matched it as STVS, right? And then when I create the volume, I can just give the um, same drive letter. So that way, like if it is XVDC, you can use the C drive, and if it is XVDS, I can use the same partitioning layout. So that way we can easily relate it. There are options to do it. Okay, there are options to identify. For example, if I go to the properties here, I will be able to understand from, okay, just backup hardware LUN 0. Okay, so this is LUN target 0, LUN 0. and go to the properties. It will take some time, okay, and then you will be able to see the details here itself. So there are a lot of details available at your operating system level. Okay, let me just go back. So this is LUN 0 volumes. Okay, there are a lot of options that you can select from here. Microsoft device driver, display name, device track. Yeah, here Zen. Okay, Zen virtualization. It is partition BD. So there are options where you can relate it here itself. I think at the root itself there were some options earlier. Yeah, you have options to find out like where exactly this LUN is coming from. So even if you go here, it will have a similar naming convention like LUN 0, target, and so on. So it is kind of in attaching state currently. So that's the reason we are not yet seeing the full details. But after it is fully attached, you will start seeing that the LUN numbers and same from the AWS platform level and from the cloud level. So coming to the clustering, right? I will show you one more option. See, if I go to this provisioned technology, you have the option to go and enable multi-attach. So multi-attachment, you can attach it for failover clustering, where it provides the NVMe driver. You have to install it in the operating system. Most of the latest Windows 2022, it has that persistent reservation and NVMe driver. If it is not there, you can install it. So you can attach the same volume to different Windows Server clusters. You can attach the same volume to multiple servers, but before these options were made available, generally what we used to have is we used to have two different data center availability zone one, and then server one, and then disk one from the data center one, and then similarly they will have availability zone server two and disk two from that particular data center, and there will be a storage level cloning that will be happening between these disks. And whenever there is a switchover or failover want to happen, the storage level mirroring will take care of the contents synchronization. So you will not have the same volume attached to multiple region or multiple data center. Instead, you will have storage level mirroring or storage level copy process that will take care of the data at the storage level. So currently there is a better option which is called multi-attached storage, but that is mainly for the provisioned IO version 2. That is what recently the customers have started using for the clustering requirement. But that is not applicable for multi-region. For multi-region, you have to have separate volumes and then do a storage level cloning. Between region, there is a asynchronous async thing. There will be a small difference in the content, but whereas within the same region, the data whatever is replicating will have exactly the same content. It is a synchronous replication, so both source and destination disk will have the same exact data, so there won't be any data loss or there won't be any recovery point objective there. Okay, and this multi-attached storage, as I said, it is available only for IO versions. For your general purpose, you won't see that multi-attached storage option. Okay, you will see only option to encrypt the volume. That is for security purpose. You can enable EBS encryption and secure your storage. So this is how you can play around. There is a lot of stuff that you have to understand. Okay, so there is a lot of learning here. Let me just see if I have some other options easily available.
Do we have a command line to find out from where the storage is coming, which line?
No, yeah, even here itself, I have seen it, but I'm just trying to find container ID device. You can find it in a graphical console only. So there are some easier options. You don't have to, but again, options are there. So bus target 1, LUN 0, target ID 1, LUN 0. Even I have seen that XVDF and all those things within the operating system. There is one more option. I will tell you. I'll come to that. Okay, Okay, let's say this is the volume which I'm referring to, right? Multi-attach, no. XVDB. Six status. So disk manager command you can use, but there is one quick second. Let me check. There is one more option called this 169.254 IP address through which you can get the details graphically as well. But before that, let me see. Disk info. This is Zen hypervisor. Think LUN 0 target 1. This is where we generally get it. Okay, I'll find out and then I will add that short tip video. But I can how to find out the volume. So AWS command line is fine. That is one option. But besides that, so one time like there was a question um, from an operation engineer. At that time, I was able to find it and then give him where exactly he can check it. But there is a option in the property itself where within this console only. But this is also one of the option where you will have the target ID 1 LUN 0. So similarly, this will have um, LUN target ID 0. So 0 means it is the first drive, and then here it will have 1, and then subsequently you will have the numbers target ID 1 and so on. So which means like it is in number order. The second one will be the best option to identify it, but there is an option to find out what is the option that we have been provisioned. So let me give you that also. 169.254, 169.254. This is the loopback IP, or they call it as sorry, relax. AWS to get disk info. So they call it as metadata service, IMDS service, okay, instance metadata service. And within that, if you want to get some of the information like the block device related or EBS volume related, there is a way to get that. So I'll show you quickly. So where is the link? Instance metadata, AWS IMDS link to retrieve metadata disk. So they call it as IMDS service, instance metadata service. Okay, so you can use the same IP. This is same across all the cloud platform. 169.254, 169.254. You can use it in every single machine, every single cloud VM. Okay, either Azure or AWS. The IP address is the same. This can help you to retrieve the AWS level information. So if you don't have access to AWS platform and you are having only access to the operating system level, so this IP will give you the complete metadata of the AWS platform level information from within your operating system itself. I'll quickly show you that. That way you know that option. Okay, it's loading. It is the capacity is very less that you have given for this EC2 instance. So that's the reason it is slightly slower. Just give me a second. It's okay. So I'll show you that. See, using this IP address, what you can do is you can get all the dynamic data and the metadata information. So if you go inside that link, you will get the information about all the disk and every single thing that you want to, whatever AWS platform level information you want to get. So if you use this command, it will have sub elements like so unauthorized the get request valid token is not there. Okay, fine. So I will get you the method to do that. So you can access the information through the metadata information, or you can use AWS command line, or even you can use the disk management command line toolset. But even it is available in the graphical console itself. Okay, coming back to the EBS theory part, let me quickly see. So at a high level, the EBS volume is mainly used for providing storage option for your EC2 instances, and you can dynamically expand as I showed you. If you want to increase the capacity for your data disk or application disk, you can do it online. But for OS volume, as a best practice, you have to bring the system down and increase that disk. You should not do it on the online. It has to be done by taking downtime. Even for reducing the size, what you have to do is you cannot directly reduce the size. Instead, you can create a snapshot, and while creating a new volume from that snapshot, you will be able to reduce the size of EBS volume. That is the best. That is the method you have to follow, because there are chances of data loss when you are shrinking the size, right? So as a best practice, AWS doesn't allow you or doesn't want you to do a direct shrink. Instead, they want you to take a snapshot, and when you are creating a new volume from that snapshot, you can reduce it from 100 GB to 50 GB or whatever size you want. So the dynamic expansion is available, but shrinking, you have to do it in a roundabout way. Direct option is not available. So based on customers' use cases, you can go and choose the type of disk you want. So if you have a large database system, go for provisioned options. And if you have data specific stuff, you can go for throughput. When you want to do some archiving, storage, and if you want to have some infrequently accessed data, you can go for this hard disk categories. So there are 3 hard disk categories, and then there are 4 SSD categories. Within general purpose, you have 2 options. Within provisioned IOPS, you have 2 options. So total of 4 SSD option and 3 HDD options are available to choose from. So based on the customer IOPS, throughput, and then the use cases, you can go for the specific stuff. So for example, for large database workload like MySQL, Oracle, MongoDB, NoSQL databases, for critical business application, you can go for IO version 1. But if your workload is very sensitive and mission critical, go for IO version 2 Express. But when you have a virtual desktop or development testing environment, go for GP2. And similarly for any archiving or infrequently accessed data, you can use the cold disk or the magnetic disk. So any questions from the solutioning side? So snapshot is something yesterday we saw, right? You can take a snapshot of a volume. It is a point in time backup. Behind the scene, this data gets stored in your Amazon S3 object storage. And whenever you want to restore it, you can utilize it. And if you're taking multiple snapshots, the first snapshot is a full snapshot. The subsequent snapshots are always incremental in nature. So in order to have a capacity level optimization, they don't do a full snapshot always. So subsequent snapshots are incremental in nature. So you get a crash consistent snapshot for your EBS volume. So it is pretty straightforward. You can just go and trigger the snapshot from the console itself. You can either take it from the EC2 instance, or you can go to a specific volume also to take a snapshot. If you want to take a snapshot of this volume, so you can go and say create snapshot, and then you can also configure lifecycle policy to automatically delete it after 3 months, or if you want to archive it after a month, you can also configure the lifecycle policy. So lifecycle manager is mainly to have the have the lifetime of your the volumes or the snapshot that you are creating. So you can say that this volume should move to archive state, or it should get deleted after a particular number of time. Automatically it will handle the life cycle of your snapshots. So any questions around the EBS volume, especially? That is where you have to be clear. See, based on the
No doubt.
customer,
I
yeah,
mean,
okay, yeah, yeah. So based on the customer expectations in terms of the performance that they are looking at, you can go and choose the right level of volume. See, not I mean, if it is sub millisecond expectation, go for IO version 2 Block Express. If it is single digit millisecond and they are not pretty much concerned about the cost and performance, then go for the latest maximum better technology as much as possible. But if they are concerned about cost and they want to have moderate performance and the characteristics expectation are less, you can go for general purpose or IO version 1, which will be a much suitable option. So if the workload is more transactional in nature, if they are having a primary dependency on IOPS, latency, and durability, always go for SSD backed storage. If they are talking about throughput workloads, which is not that performance sensitive, you can go for HDD backed storage, where you will get a lot of less cost services. Okay, performance.
What's the difference in pricing, Stan, in
Uh-huh.
GP3 and IO1?
Okay, so GP3. Okay, so let me give you how to do that. So AWS has got a pricing calculator. Okay, this is what you will be using for every pre-sales opportunity, or even for understanding the difference between two categories. You can use this pricing calculator tool. I will walk through this later as well, but for now I will just show you how to uh, explore these options. So I can search for the service, so that way it is easier. So you can select the EBS volume and configure it here. And first, let's try the pricing for GP version 3 is what you asked. And for the same 30 GB capacity with 3000 IOPS and so on. So the calculation per month, you will see the pricing at the very bottom. So for now, whatever for 30 GB is free of cost per month, right? So that is the free tier category. Let's say I need 60 GB, I need daily 2 snapshot, that should be fine. So per GB, how much capacity, this is fine. Number of snapshots is not needed for now. So currently, this is what still they are showing. Let me go and increase the capacity. Let's say 500 GB. Directive snapshot. Where is the calculations? Are here? It is right. So 70 USD for 500 GB, right? For actual 500 GB, it is 40 USD is the storage cost, but for the snapshot and the other IOPS based on that, it might go up to $70, but the actual cost is $40. Similarly, I will show you for IO version 1 is what you asked. Okay, so baseline is $60, and then it might go up to $286 based on the IOPS and the usage cost. So if it is IO version 2, it will be much costlier for the same capacity, same concept. The baseline is 62, and then the actual pricing might end up around 300 USD, or 287 to be precise. So this is how you can understand the comparison or the cost difference between a two option. Even there is a straightforward option that might be
Thanks.
available in the AWS EBS pricing screen. But if you want to get the exact pricing, then go for the pricing calculator. So on the screen itself, you will see, you can also request for a quote from AWS itself. If you are not clear, you can use it. You can also view the details from here. For example, this is the baseline that I was talking about for GP3. This is the baseline amount for $0.040 dollars, and then for your IO version 2, 0.125 per GB per month, and IO version 2 IOPS option, this is the thing. So this is the baseline price, but if you want to get the actual pricing, click on this calculator and you will get it. Okay, so any other question
So
on EBS?
basically, any non-critical workload,
Mhm,
we can use the general purpose part,
mhm,
and any critical mission critical
mm,
workload where high availability is required,
mm.
it's recommended to go with the provisioned IOs.
Mhm. So yeah, true. That understanding is correct. On top of it, see, general purpose, we generally end up choosing that when the customer or when the application owner or when the business owner is not really sure of what exactly they are looking at, in terms of throughput or IOPS, in terms of the capacity. If they are not very clear, then that's where we always end up with general purpose. So most of the time, like maybe 80% of the time, the general purpose will continue to be used even after a month or two, even after a few months. But if the customer is concerned about the performance, and if they want to enhance the speed or want to get more throughput and stuff, then that's when you have to go and understand how much from the monitoring data, what exactly is the expectation and so on. And then you can try to convert it, try to change it to higher provisioned options, and then you will be able to do it. So that conversion options are available in the console directly. For example, if I want to convert this to a different category, I can go and click on modify. So currently it is general purpose version 3. I can go and change it to this thing. And then they are saying the increment I was talking about, right? That's where it will be a challenge. It should be in a 4 GB increment. So I can just go and say 8 GB. Then the maximum IOPS, I will say I just need 400 IOPS, and then click on modify. So if you're increasing the volume, you have to extend the file system. That's what they are saying. So you can do it, but always check whether you have the limits and all those things. So I've already done multiple changes. Okay, so I have to wait for next few couple of hours to make the changes. I've already made 2-3 changes on the same volume. So if you're making too many changes, then I've told you, right, there are chances of data corruption. So AWS also has that throttling. They will not allow too many changes on the same volume within a time span, but you have option to do it. So always try to do some kind of play around, and then only you will get to understand, and you can suggest customer how much time it will take for all these activities. So there are two important things: EBS volume, EBS snapshot. They are tied to each other very closely. So EBS volume is what is directly attached to your EC2 instance, and you store your data. EBS snapshot is nothing but it is the point in time backup that you take in order to have a rollback option. If there is something that happens wrong on your operating system, or some issues on your data, you have options to roll back, restore the previous state using the snapshot option. So there are multiple volume types that are available. We need to understand the performance characteristics, cost implication against those HDD and SSD option. That way we will be able to choose the correct option for the sensitive workloads and non-sensitive workload. And you also have a separate option called AWS backup, which we will discuss later, through which you can take the complete backup of your EBS volume and restore it whenever you need it. And then you also have to encrypt the disk for mission critical workload. On top of using the better sizing, better performance, you also have to think about the data encryption, data protection. So taking backup is also essential. Encrypting the data is also very, very important for a sensitive workload. So scalability aspect, as I told you, it is dynamic. That's the name itself. It is elastic block store. You can elasticity is there. You can go and expand it. Dynamic expansion is possible, and the fine tuning of the performance will take some time. So expansion will happen immediately, but then the optimization will take some time. And after the optimization only, you will realize the performance. Some people will go and change it, and then they will start testing the performance. It's not like that. So it will take at least 3 to 4 hours based on the capacity. If it is a very big size, like for example 500 GB or 1 terabyte disk, the optimization can go up to 1 day also. So maybe you have to start testing the performance the next day, or after 8 hours, or after giving the time for the optimization and the tuning to complete. So some people will convert it, change it, and then they will start testing after a couple of minutes itself. That won't work. You will never get that, because there will be a lot of caching. There will be a lot of data that is still there on the old disk. So AWS at the platform level, they have to move the data from the current disk to the new disk technology. For example, from general purpose to the IO version 1, or IO version 1 to IO version 2 block express. There has to be some fine tuning. There has to be some movement that has to happen on the backend. So only post which you will be able to start realizing the performance benefit. So keep that in mind, and whenever you are making changes and testing, give ample time for the optimization and the performance tuning from the AWS team to get completed. So availability wise, as Moby said, we have to always think about the high availability and durability expectation of the application. If you want to prevent the loss of data, then IO version 2 Block Express has the highest annual, better annual failure rate, highest availability and durability is there for that. So you can choose it. Archiving, so you have multiple options. You can archive it in S3 Glacier, or you also have cold storage, where you can also store the less frequently used data and archive them. So this is how you can play around, and this is what is sufficient for the EBS. Okay, so any questions before we move on to EFS? Okay.
Stanley,
Mhm.
I just want to know for the high availability, even
Mhm.
Azure and AWS are in the same criteria, right? There is no
Uh-huh.
much downtime, right?
Okay, so availability, high availability at what level?
Normal the server.
Okay, server. Okay, so see, yeah, it depends, right? So AWS and Azure, Microsoft provides a lot of option. See, when you're talking about server, if you have one server, then it is a single point of failure, obviously, right? So it is going to have impact if that one server goes down. So if you're having two servers, then you can either place it in two availability zone, or you can place it in two different region, or whatever, like the maximum possible. So all these three options are available in Azure and AWS. When it comes to storage, generally what they do is they store 3 copies by default. Okay, so that is what they call it as local redundant storage option. This is available in AWS as well as in Azure. So they call it a zone redundant storage. The 3 copies will be stored across 3 different data centers if you are choosing a zone redundant option. They also have a geo redundant storage where they will have 3 copies in the primary region and 3 copies in the secondary region. So behind the scene, Amazon or Microsoft, either in Azure or AWS, they maintain multiple copies for the storage level. But if you're talking about server level, you will have to create more servers and configure clustering to achieve higher availability. You have to scatter the server across 2 different data center or 2 different region. There is one more topic called placement group option, where you can spread the servers in 2 different racks or 2 different um, or 2 different availability zone or region. So there are 4 levels of option where you can increase the high availability. If you're going for 2 region and having servers in 2 different region as a disaster recovery, you get the best availability and durability for your application. It's all about the placement. It's all about the number of servers you have and how you place it. But for storage, by default, they have 3 copies stored. So if one storage device goes down, you won't be having any impact. So if only 3 storage goes down, it's like a RAID 5 across multiple storage, physical storage. So yeah, the data loss is very, very minimal. That's the reason they are giving you annual failure rate of 0.001 and 0.1 and 2. The annual failure rate is very, very less. So if you're going for geo redundant storage, they give you up to 99.99 of durability, which means if you have around 10,000 files in your storage, one file can go missing in 1 million year. Okay, so there is a very rare chance of data getting lost if you are going for the highest possible durability option in AWS platform. The same option is available between Amazon and Microsoft. There is no difference, not much difference between AWS and Microsoft Azure there. Even the technology also will evolve, and they might use the same technology behind the scene, NVMe cards, IO Express, Block Express. So they will continue to utilize the same option as the competitor.
Now, before
Yeah,
you
absolutely.
start the next
Mhm,
one,
mhm,
uh, see, you are a. I mean, I understand by the way you talk.
mhm.
You are like a multi-cloud expert
Okay.
for an year. See,
Mhm.
I work predominantly. I worked on Azure for a long time.
Okay.
AWS is something like
Mhm.
I have worked here and there, but not much.
Mhm.
See, being a solution architect,
Mhm.
the first question that will arise for any of the discussion that we went, which would be the cheaper,
Mhm.
you know, uh, cloud
Mhm.
provider,
Mhm.
is it Azure or AWS? What's your
Mhm.
thought process in that?
Mhm.
Which could be the costlier, or which could be cheaper?
Okay. See,
Both are offering a
mhm.
different quality, or
Mhm.
I understand that, but
Mhm.
yeah.
So, coming to the purchasing options and the pricing model, right? Both AWS, I mean Microsoft and Amazon, they got similar purchasing options, similar pricing model.
Yeah.
Whereas if you take another provider into consideration, like the third biggest provider is Google,
Google.
right? So they provide a different model. But when you talk about Amazon and Microsoft, pretty much the models are the same when it comes to reservations or
Okay.
savings plan, or when it comes to how you purchase it, it's all same. But when you come to Google, they have a sustained usage discount model. So the more you consume, the more you use, the more you have the relationship with Google, they will automatically reduce the price based on the sustainability,
Right.
sustained usage model. That model is completely different. But when you talk about Microsoft and Amazon, so pretty much the purchasing options are the same. But when it comes
Mm,
to the workload level comparison, so for example,
mm,
Microsoft is there in the market for 30 plus years. In the IT industry, they are at least 30-35 years into the market, right? So IT market. So they
mm,
have their own
mm,
Microsoft Windows operating system. They have their own Microsoft SQL databases. They have their own technology of applications and so on. So if your
mm,
workloads
mm,
are hosted on these operating systems and databases and applications, they have
mm,
edge there. Okay, they have an option where they can give you better discount in terms of volume pricing or discount model. They can show a
mm,
difference there. But if you are comparing
mm,
running a Linux on Microsoft and Amazon Linux, then there will be a better edge on
mm.
the Amazon side. Okay, and then based on the
Okay.
subscription licensing and all those stuff, Amazon AWS
Mm,
will give
mm.
you a better option. But when you're talking
That's
about
option.
the
Okay.
disk pricing or whatever the other component pricing, more or
The
less very
network,
very
the
yeah,
network, or yeah.
network that will be only a very very small difference. But Amazon will
Mm,
be much cheaper, was much cheaper 6 to 7 years back. Okay, because they had their
okay.
own network backbone across the globe. I was
Mm,
telling on the second day or first day I was explaining. So Amazon has
mm,
invested like anything on their in the infrastructure piece. Their data center size was
mm,
6 times bigger than all the competitors put together: Cisco, Microsoft,
mm,
HP, Dell,
mm,
IBM. All these companies infrastructure
mm,
put together was 6 times smaller
mm.
than Amazon AWS data centers.
Amazon.
Yeah, so
Okay.
that much
Okay.
of infrastructure investment they have done in terms of server, storage, network, and whatever backbone connectivities and all those things. So they have invested like
Mm,
anything, and the customers were getting a lot of benefit because it's all their own backbone network across the globe, their own storage technology, their own. Now, I mean, when they started the business, it was not the case. So when they started the business, they
mm,
had tie up with different storage provider. For example, in Asia Pacific, they
mm,
used to talk to Hitachi. In
mm,
In Americas, they
mm,
used to have tie up with Dell and so on. So they used to have a partnership and then they used to provide it. But if you talk about today's status, Amazon manufactures its own server, its own processor, its own storage device. So they have their own
mm.
inbuilt manufacturing. They are reducing the price. They have reduced the price 8 times since their launch of a particular product or service. So EBS price in
Okay.
2008 is completely different. Currently, it is like 8 times or 10 times cheaper since the launch date. The reason is Amazon has
Okay.
changed the way that they are providing the service. Initially, it was a partnership, and
Mm,
then now it is all in-house developed hardware,
mm.
in-house developed product. They are able to reduce the price, and the more you consume, the more you have relationship with any cloud provider. You will get better discount models and better enterprise agreement where you get the cost benefit. But yeah, I mean, you have to look at case to case, the workload level, and you
Case
have
to
to,
case.
yeah,
Mm,
case to case, you have to list down the services, products that you are going to consume from Microsoft and Amazon.
mm,
So that way you will get to
mm,
understand. You can figure it out. But or I mean, talking at a high level, this is how I can explain. Okay, but you have to get into the nitty gritties of the OS database database, the licenses, subscription, the technology of disk you are using, the network, the performance that you are getting. So you have to compare it, and then you can come to a conclusion. See, that kind of
Definitely, this is
comparison.
not an apple to apple comparison.
Correct,
Yeah,
correct. Yeah.
this is more of a case by case. Okay, got it.
But you get more or less same thing from both the vendors. But see,
Both the
90% of the 80% of the case, I would say the vendor might already have
mm,
chosen it. They will say, go and
mm,
host your workloads on AWS or Azure. So that's how
mm,
you get
mm,
directions.
mm,
Very rarely,
mm,
customers,
mm,
maybe
mm,
internal application owners or internal customers, they
mm,
might
mm,
involve you for specific thing. If you are working with a specific customer for longer duration, let's say 5 years, 10 years, then they might have confidence on you,
mm,
and then they will come and ask you what to choose, and as a service
mm,
provider, what option you have. Otherwise, they
mm,
will have their own in-house
mm,
architects, enterprise architects, who will be the decision maker
mm.
on which cloud to go for. Even, I
Okay,
mean,
got it.
many
And one
Fortune
more.
100 companies, they go for multi-cloud. Okay, so
Mm,
it's not like they are going to end up.
yeah.
Yeah.
Mm, mm. And one more question.
Mm,
See, at least I would say,
mm,
in my experience for some time,
mhm,
uh, after this W360 or M365,
mhm,
Microsoft 365. I
mhm,
mean, the moment the 365 options coming out,
mhm,
at least once in a month or once in 2 months, there is an outage from Microsoft anywhere. It's always the Teams will not
mhm,
work, or the
mhm,
the complete Office 365 product having an issue, and it goes a task, and it'll 8 hours, 10 hours, it won't work. Then it'll come up. Microsoft has the challenge because of the volume. They have the huge volume now
mm,
across globe. There's so many Office 365 users.
mm,
Would you compare that, with any of the serious service? I mean, yet a service which has been offered in Amazon on a large scale, and will that goes on a task? I mean, in your experience, I'm asking,
mm,
because I use, but there are so many calls we attended. The Microsoft 365 goes down,
mhm.
and we'll be waiting, and we'll be raising a ticket with Microsoft. We'll waiting for them, and it'll at all of a sudden it'll suddenly started working.
Mm.
So, is that the same case to Amazon too?
Okay. See, Microsoft 365 is widely used. It is completely software as a
Yeah,
service
widely used. Yeah.
where you have
Yeah.
a lot of dependency, and the technologies behind Microsoft services are their own operating systems and databases and so on, which is not, I mean, I won't say it is used by the enterprises, but it is not as solid as the enterprise product like Oracle database, or maybe some kind of mainframe products, or it is not as rigid, and the updates that you get for Microsoft is very often, right? Whereas if you compare it with the other stable product, the updates that you get for other products are comparatively less, and the options that you get to do at the graphical level is very user friendly, and there are a lot of options to play around with Microsoft, and people go and play around a lot of options, configuration settings and so on, and
Mm,
it
mm,
is prone to outages or any small changes. See, even the CrowdStrike issue that we discussed the other day. See, it all
mm.
a small thing, but then it ended up impacting at the large scale, right, at
Yeah,
the huge scale.
impacting a lot. Yeah.
So Microsoft is definitely trying to fine tune it, optimize it to get higher availability. But
Mm,
because of the
mm,
large scale, because of the dynamics of the
mm,
backend operating system databases and the technology they are using, they have
mm,
to first
mm.
stabilize their backend systems to less modifiable systems. For example, like I mean, Microsoft has taken that route long back. It is not easy to do it overnight
Long
or
by. I
something
mean,
like
yeah.
that.
If you
Yeah.
see if you see NT4 machine getting a
Mm,
blue screen, and 2000
yeah.
machine getting a blue screen, 2008 they were reduced, and 2012,
Correct.
2016, 2019. Now
Yeah.
it is 2022. It's one far better. Yeah.
Yeah, it is
It
getting
can't
far far better.
comparable.
Yeah, compared to
Yeah.
that one. And on top of that, see, the options that we had earlier was very minimal. For example, in
Mm,
2003 or whatever, we used to have only the graphical friendly installation option. But nowadays, you have the option to go and install a core version where you don't have any kind of graphical fancy things. You get only solid core firmware and the operating system, where the options to change or play around is very, very minimal. And people, when they make change, they try it out twice, thrice, and then they go and touch it. But when it is graphical, it is prone to make changes. People go and try out things, and then it did get down. But yeah, they are making a lot of enhancements, and the options are on the way. But over the period, as you said, see, 4 years, 5 years back, the technology that they might have used for Microsoft 365 as a backend might be in older technology, OS or databases. But now it will be a much better project, I mean, product behind the scenes, and they might evolve. See, but they are growing like anything. In the last 4-5 years, they have catched up a lot of market. Amazon was kind of monopoly in public cloud IaaS, infrastructure as a service, and then even on the platform as a service to a certain extent. But software as a service market is mostly with Google and Microsoft and companies like
Microsoft.
Salesforce and others. But Microsoft is way far better. I mean, in terms of the customer base, Microsoft is the leader in software as a service segment. Yeah.
Got it.
So yeah,
Got it.
Amazon downtime, you won't hear like that, because they don't have a lot of software as a service like what Microsoft, Oracle, and companies are offering.
Microsoft.
Yeah. So Microsoft offering is very different. So you cannot compare Microsoft software as a service offering with Amazon's infrastructure as a service offering, which is tied
Amazon
to a
service.
specific data center, specific region, and so on. So if the downtime is happening, it is only at the data center level or the regional level. So the large scale impact won't be there. But the Microsoft offering 365 is globally used, and the challenge is the way that they are distributing the services. See, initially they had the distribution globally at the US, and if something goes wrong at the US side, entire world is impacted. But now at least they are regionally started distributing into
Correct.
like EMEA, Europe, and I mean, sorry, the Asia
Europe.
Pacific, Oceania. They are splitting it down. At least they have the primary distribution point starting from the region, so that if there is an impact, it is limited to a region or to a particular country. They are doing that also in parallel, but it will take some time. It will take at least 2-3 years. It won't happen immediately. You'll start realizing the benefit after a few years. Yeah, for now it is comparatively not as much as stable like the other providers, but it will eventually get better in some time.
Thank you,
When I'm
Stan.
talking
Yeah,
about
thanks a lot.
Microsoft Azure, yes, yeah. So okay, we have got only 17 minutes. Okay, that's interesting. Okay,
I have just
no problem. That's
deviated
fine.
many of your topic
No,
today.
that's fine. See, that's where that's the reason you come and attend this live sessions, right? See, if you want to
Yeah,
just listen to this, then already there are a lot of recordings and online contents that are
correct,
available. So
correct.
here we
Yeah,
come for
yeah, yeah. I
discussions,
mean,
right? Yeah.
I just want to something out of your experience. That's why
Yeah.
I'm just posting some.
No worries, no
Thank
worries.
you.
That's fine. So then, what we will do is I need more time for that other topic, which is EFS. EFS can be discussed a little later also. So we have just discussed about the EBS today. Okay, fine. Uh, let's just stick with the questions around the EC2 instance and EBS. So far we have covered up the EC2 options plus the EBS volume. So maybe tomorrow we will jump on to auto scaling and elastic load balancing. Next week we will talk about the storage options, including S3, EFS, and other options. So auto scaling and load balancing is what we will discuss tomorrow. Any other questions before we conclude on the EBS, Elastic Block Store? Fine. If there are no questions, then we will connect tomorrow. And as I told you guys, you can continue to watch